Okay, now this one's a little more difficult, but I know we can do it. So in this one we have Nora, and she is jogging to the bank, which is 4.3 kilometers from her house. And she's jogging at a pace of 4.0 meters per second. How long has she been jogging when she reaches the bank? So we have 4.3 kilometers. Kilometers are a distance, so that's going to be a D. We have her pace. A pace is just like a speed, but if you don't know that, you see that it has the units of meters per second, so that's just like a velocity or a speed. And so the units give it away, and then it says how long. Okay, so that's a time. So I'm going to do just like I did on the last one. This is a little more difficult, but it's okay because I'm going to do just what I did on the last one. My velocity is 4.0 meters per second. Okay, it looks like she runs as fast as that bike, so that's pretty good. Her distance is 4.3 kilometers. Now, do you see that her speed is in meters, but her distance is in kilometers? Before you put it into the problem, you want to go ahead and you want to just convert those kilometers to meters, just like we did in Unit 1 when we did conversions. So we have kilometers over here. We want to get rid of kilometers, so I'm going to put them on the bottom. And we want meters, so I'm going to put those on the top. Now, a kilometer is almost a mile, and a meter stick is a meter's the size of a meter stick. So there are 1,000 meter sticks in 1 kilometer. It's pretty far. I'm going to cross out my kilometers, and then I'm just going to put it in the calculator. You can do it by yourself, but I mean, why not put it in the calculator and make sure you get the right answer? It doesn't hurt anyone. So I got 4,300 meters, and then the thing I want is time. Now, right here, they put the time as seconds, so I'm going to go ahead and I'm going to put time as seconds right there. That way I don't have to do another conversion. Okay, we're going to use the same formula. V equals D over T. I'm going to go ahead, I'm going to put it in the triangle because I don't like doing algebra. So I have V equals D over T. In this problem, we want time, so I'm going to kind of cross out time, and I'm going to get time equals D over V. Okay, so now I'm just going to solve it. Time equals distance divided by velocity. I know that you don't have to put it in the in this train track thing, but I really like doing it because it just makes sure it's another check. And I would rather take a couple extra seconds and get the right answer than kind of rush through a problem and then get the wrong answer. But, you know, that's just me. So I'm going to put my distance on the top, and I'm going to put my velocity of 4 meters per second on the bottom. Now my meters are here, and I'm going to put my seconds on the top because the meters and the seconds, they can't be on the same side because it's meters per second. They have this line dividing them, and so they'll have a line dividing them here. Okay, so I'm going to cross off my meters, and I'm going to cross off my meters, and you see I'm left with seconds, which is good because that's what we wanted. So I'm going to do 4,300 divided by 4, and I got this in my calculator. Okay, that's 1075 seconds. You're more than welcome to leave it that way, but 1075 seconds doesn't mean a ton to me. So I just kind of want to get an idea of how many minutes that is, because that makes more sense to me. But again, you can leave it in seconds. So I'm going to put seconds on the top. I'm going to put seconds on the bottom. That way they'll cross out. And I have 60 seconds in 1 minute. Cross out my seconds. Cross out my seconds. And that's 17.92 minutes. Not too shabby. Can you run for 17, almost 18 minutes? So this is the answer in minutes. This is the answer in seconds. You can leave it either one, but make sure you put units. Otherwise, I have to assume elephants. And 1075 elephants doesn't make any sense for time. Neither does 17.92 elephants either, actually. So this is kind of a medium hard one. And let's go to a hard one.